Ever wondered what holds the universe together? Well, the answer lies not in the stars or in the galaxies far, far away, but right here on our own planet, in the tiniest particles that make up everything we see, touch, and even breathe. It's the magic of chemical bonds, the invisible glue that binds the universe together. Now try to imagine the universe as an enormous jigsaw puzzle. Each piece of this puzzle represents an atom, the basic unit of matter. Just like a jigsaw puzzle piece, each atom has a unique shape and size that allows it to connect with other atoms in a specific way. And when they do connect, they form what we call molecules. But atoms don't just randomly stick together. Oh no, they follow a set of rules like a cosmic code of conduct, and this is where chemical bonds come into play. Chemical bonds are the forces that hold atoms together within a molecule, like a handshake that seals a deal. There are several types of chemical bonds, each with its own unique set of rules and characteristics. Some atoms prefer to give and take, like in an ionic bond. Others prefer to share, forming a covalent bond. And then there are those that form a special bond, a hydrogen bond, which is essential for life as we know it. But why do atoms form these bonds, you may ask? Well, just like us, atoms strive for stability. They want to be in a state of minimum energy, where they can just chill and be content. And forming bonds helps them achieve this state of bliss. So next time you look at a glass of water, remember that it's not just H2O. It's a tiny universe held together by chemical bonds. From the air we breathe to the food we eat, from the clothes we wear to the gadgets we use, everything around us is a result of these fascinating bonds. So, in a way, we're all just cosmic puzzles waiting to be solved. Ever heard of the phrase, opposites attract? Well, it's not just for magnets. Let's dive into the world of atoms, where this rule plays out in the form of ionic bonds. Now you might be thinking, what in the world is an ionic bond? Well, it's essentially a give-and-take relationship between two atoms. Let's imagine two friends. Chatterbox Charlie, who could talk the hind legs off a donkey, and listener Lucy, who could listen for days on end. In our atomic world, Charlie is like an atom that has an extra electron it doesn't need. He's got so much to say, but not enough space to keep all these words. On the other hand, Lucy is like an atom that's missing an electron. She's got plenty of room for more words, more stories. So, what happens? Charlie, the generous soul that he is, gives away his extra electron to Lucy, who happily accepts it. This generous act creates an ionic bond between Charlie and Lucy, or rather, between our two atoms. Charlie, now having lost an electron, becomes positively charged, and Lucy, having gained an electron, becomes negatively charged. And voila, our rule of opposites attract comes into play. The positive Charlie and the negative Lucy attract each other, forming a bond that's hard to break. But why does Charlie give away his electron in the first place, you ask? Well, atoms are all about balance. They strive to have a stable, full outer shell of electrons. So if giving away an electron achieves that, they won't think twice about it. The ionic bond, this transfer of electrons, this giving and taking, is one of the fundamental principles of chemistry. It's the basis of countless reactions and the formation of many compounds we encounter daily. So, remember, in the world of atoms, sharing isn't caring. Giving away is the way. But wait, didn't we just say that in the atomic world, giving away is the way? Well, not always. Imagine this, you have a car, but you're short on gas. Your friend, on the other hand, has plenty of gas but no car. You both need to reach the same destination. What would you do? That's right, you'd carpool. You share your ride, your friend shares their gas, and you both reach your destination. This, dear listeners, is the essence of a covalent bond. Covalent bonds are like the carpool of the atomic world. Instead of cars and gas, we have atoms and electrons. These atoms, they're not into the whole give and take thing, they're more into sharing. They're like those friends who always bring a dish to the potluck, ensuring everyone gets a taste. In a covalent bond, atoms share electrons to achieve stability. No one's losing, no one's gaining, everyone's sharing. It's a win-win situation, like finding a parking spot right in front of your destination. Picture two oxygen atoms, cruising down the atomic highway. Each has 6 electrons in its outer shell but needs 8 to be stable. They could go looking for other atoms to take from or give to, but why bother when they can share? So each oxygen atom shares 2 of its electrons with the other, filling up their outer shells. Voila, we've got a covalent bond, and they've formed a stable molecule of O2. Covalent bonds are a big deal in chemistry, folks. They're responsible for creating a multitude of molecules, from the water we drink to the DNA that makes us who we are. Without them, life as we know it wouldn't exist. So the next time you share a ride, or a meal, or a simple moment, remember the covalent bond. Remember that in the atomic world, just like in ours, sometimes sharing is indeed caring. Now let's talk about a bond that's a bit of a celebrity in the world of chemistry. Imagine a hydrogen atom as the most popular kid in school. You know the type? Everyone wants to be their friend. They're always at the center of every social circle, just like our friend hydrogen. Hydrogen with its one proton and one electron is like that popular kid, always forming bonds with various other elements. But there's a special type of bond that hydrogen forms, and it's a bit like being best friends with the cool kid on the block. This bond is called a hydrogen bond. Now don't get it twisted, this isn't your everyday run-of-the-mill bond. No, siree, this bond is more of an attraction, a kind of chemical flirtation if you will. It's a special type of attraction that occurs between a hydrogen atom in one molecule and another atom, usually oxygen or nitrogen, in a different molecule. This is due to the electronegativity of these atoms. Big word I know, but think of it like this. Some atoms just have a magnetic personality, attracting others to them. So essentially, the hydrogen atom, our popular kid, is attracted to these electronegative atoms. It's like when the captain of the football team, who's friends with everyone, also happens to have a soft spot for the head cheerleader or the class president. These hydrogen bonds, although weaker than covalent bonds, play a crucial role in the structure of water, DNA, and proteins. Without them, life as we know it would be quite different. It's like without the popular kid, school just wouldn't be the same, right? So you see, our popular kid hydrogen has a lot of power in the world of molecules, forming bonds left, right, and center, and even having special bonds with certain atoms. So when it comes to chemistry, it's all about who you know. So, what's the big deal about these bonds anyway? Well, let's think about it. It's like asking why relationships matter in our lives. Just as our relationships shape us, influence our behaviors, and define our identities, chemical bonds, in a similar fashion, give identity to the molecules they form, and these molecules, in turn, are the building blocks of life. Let's start with the humble H2O, or as we commonly know it, water. The hydrogen bonds in water make it a liquid at room temperature, allowing it to flow and fill our oceans, rivers, and lakes. Without these bonds, water would be a gas, and the Earth would be a very different and likely uninhabitable place. So the next time you're sipping on a glass of water, remember you're enjoying a marvel of hydrogen bonding. And it's not just about the water we drink. Chemical bonds are at the heart of every biological process that keeps us alive. Our DNA, the blueprint of life, is held together by hydrogen bonds. These bonds allow the DNA to unzip and replicate, passing on genetic information from one generation to the next. If these bonds were any stronger or weaker, life as we know it might not exist. So every time you look in the mirror, remember, you're witnessing the magic of chemical bonds. In essence, chemical bonds are the unsung heroes of life. They're the glue that holds everything together, from the tiniest water molecule to the most complex DNA strand. They're the architects of the physical world, silently working behind the scenes to make life possible. So, next time you enjoy a glass of water or look in the mirror, remember, you're experiencing the magic of chemical bonds. In the grand scheme of things, they're not just a big deal. They're the key to life itself.